Okay, now we're going to be doing the same thing we did with the last lesson, finding relative extrema, but the function is going to get a little bit more complicated. This function that we're going to look at here is a rational function, and it has a vertical asymptote. So the first thing we do is figure out where its vertical asymptote is, because that's really important in the graph, and that everything can change there. So if you remember, a vertical asymptote happens where the bottom equals 0. So in this function, the bottom equals 0 when x squared equals 0, or x equals 0. That is a vertical asymptote. So that's going to be an important point on the graph. So now we're going to find the critical numbers, and it's the same thing. We take the derivative of this function, and you can do it with the quotient rule. You can split it up and do it that way. But when you're done simplifying, your derivative will look like this. We need the derivative because we need to find out where it has critical numbers. So we set the derivative equal to 0. Those would be the critical numbers. So a fraction equals 0 when the top equals 0. So we'll set the top of the fraction equal to 0. Divide by 2. Add 1. Fourth root both sides. And when you even root, you get a plus or minus. And the fourth root of 1 is still 1. So these are your two critical numbers. So when we make our chart to see where it's increasing and decreasing, we need to use both critical numbers, but you always also have to use vertical asymptote. So I'm going to draw my number line just like before. Put in the critical numbers in the order in which they occur, the left one, the right one, but then also the vertical asymptote, which is at 0. So that should go right between them. And I'm going to draw it with a dashed line because I don't want to call that a relative min or max because a vertical asymptote doesn't really exist on the graph. But the graph can change there, so I need to consider it. So just like before, here are my intervals. Negative infinity to negative 1, negative 1 to 0, and so on. Now, also just like before, I'm going to test the number here in the first interval. I'll use negative 2. So we had to figure out what the derivative at negative 2 is. My derivative is right here. So when you plug in negative 2 to the derivative, you'll get a positive number on top because 8 minus 1 is positive. And you'll get a negative number on the bottom because negative 2 cubed is negative. So you get a positive divided by a negative, which is a negative, which means we're decreasing here. And I'm going to do the same thing with the other intervals. This one's a little tricky because between negative 1 and 0, there's not much to choose from. It has to be a fraction. So I'm going to find the derivative at negative 0.5. If you plug it into the derivative here, you can use a calculator if you're more comfortable with that, but negative 0.5 to the fourth is a small number, positive, and the small number minus 1 is negative, so the top's going to be negative. And negative 0.5 to the third, since it's to the third, is still going to be negative, so you'll get a negative over a negative here, which is positive. Now, this is an increasing interval. On the next interval, we're going to use positive 0.5 because that's between 0 and 1. When you plug that into the derivative over here, nothing changes on the top. It's still a small number minus 1, which is negative. But on the bottom, since we have positive 0.5 cubed, that's going to be positive. So we have a negative over a positive, which is negative, which means the function is decreasing in this range. And finally, from 1 to 0, or I put 1 to 0, I meant 1 to infinity. Not sure if that's a mistake. We'll call it a mistake. From 1 to infinity, you can use any number. Let's just use 100. Obviously, when you plug in 100 to the derivative, you'll get a positive up top and a positive on the bottom, which is positive over positive, which is positive. You have increasing. So now you can say it's decreasing from negative infinity to negative 1 and from 0 to 1, and then increasing from negative 1 to 0, and then again from 1 to infinity. Now, to find the relative extrema, you can picture on this first interval is decreasing, and then it goes to increasing, which means this is a min. Even though it goes from increasing to decreasing here, don't call this a max because it's not there. It's a vertical asymptote. That's why I drew it with a dashed line. So we can ignore this as far as calling it a min or a max. Going from the third to the fourth interval, it goes from decreasing to increasing. So here is another min. This function has two relative minimums and no relative maximums. So the relative minimums are at, scroll up a little bit to remember, -1, comma, something, and also at 1, comma, something. Some things, you'll just plug in the -1 and the 1 into the original function, which was this. Let me grab that, bring it down. So when you want your points, you're plugging the -1 and the 1 into the original function. So when you plug -1 into it, you'll get 1 plus 1, which is 2, over -1 squared, which is 1. So it's going to be 2. If you plug in 1, you'll get a positive 2 over 1, which is 2. There's your relative. To check this on a calculator or with any graphing software, you just plug in the original function. You can see from the calculator, it looks like a min at -1, 2, and 1, 2. You can also calculate the minimum calculator. Both of them, actually, this I only did the left one. It turns out to be -1, 2, as we expected. So that's it.